So we've been dealing with the happy path and we've not concerned ourselves with what could possibly go wrong with what we're doing at the moment. But it's time to start thinking about that. And this is the part where microservices become significantly more complex than what we do in a monolith type application. And let's just do a quick comparison of the two and why they're so fundamentally different in how we have to deal with the things that could go wrong for each one of these messages, really. So let's take a look at an example of a monolith. So a post request comes in to create an auction and it hits our auction app API, and this is if it was a monolith. So inside the auction app, for example, we might have two tables that need updating, and then we would save the changes, and this happens inside the transaction. And then once the save changes is called, then the database is updated. But if any of those actions before the save changes fails, or the save changes itself fails, then all of the transactions fail, or everything inside that transaction fails and everything is rolled back. So there's no way in this kind of application that we could have data inconsistent if we were updating two tables at the same time, as per this example. And that's because in a monolith application we'd be using ACID transactions, and the ACID acronym, the atomicity, each statement in a transaction to read, write, update or delete data, is effectively treated as a single unit. Either the entire statement is executed or none of it is executed, and this prevents data inconsistency. And the C stands for consistency, to ensure that transactions only make changes to tables in predefined predictable ways. Isolation refers to multiple users reading and writing from the same table at once, and durability ensures that successfully executed transactions will be saved even if the system fails. And really, Entity Framework would take care of that for us in the main part for a normal, typical monolithic application. But we're in a different world with microservices. And if we take a look at the transaction, let's call it a transaction, that we're doing when we create an auction, how we currently stand at this moment in time. So the post request is going to come in and it's going to hit our auction service. Now, our auction service is going to create that auction and it's going to save it into our Postgres database. After that, it's going to publish a message to the service bus, and our search service is going to consume that message, and then it's going to update the MongoDB database. Now, supposing, for instance, we were to lose any of these services. Supposing we lost our Postgres database, supposing the service bus was down, supposing the search service was down, or supposing our MongoDB was down. What's going to happen with that particular transaction, if we call it a transaction? Are we going to have inconsistent data? Are we going to have data in our Postgres database and not in our Mongo database? And if so, what do we do with it? Well, first of all, let's try a little thought experiment. And if one of our services fails and a user attempts to create an auction whilst that service is down, will the auction service database and the search service database be consistent? Now, there's a little chart here, and I've filled out the first box for you to say that if the auction service is down and all the other services are up, will our data be consistent? Will the same data in the auction service be the same as the data in the search service? Now, I've put a green tick in for this one, and why is that? Well, if our auction service is down, then the client cannot create an auction. So it's never going to update the PostgreSDB, it's never going to send a message to the service bus, and it's never going to update on the MongoDB either. So even though the creation of the auction has failed, we would not have to deal with data inconsistency. So please take a moment to think about this and take a look at what we're doing when we create an auction, and just fill out mentally in your head the different boxes here. For example, if the Postgres is down, is that a tick or is it a cross? And same for if the search service is down, the MongoDB is down, and the RabbitMQ is down. So please pause the video, take a moment to think about that, and I'll continue and explain what is going to happen in each of these different scenarios. So let's take a look then. And what does happen if we lose one of these services? Well, we already know that the auction service If that's down, the user can't create a database at all, and we have data consistency. Both our Mongo database and our Postgres database are the same. If we lose the Postgres database, then based on how we've written the code, if our Postgres database is down, then that's going to throw an exception when we try and save changes into that database. That means the request is stopping execution at that point and the auction is never created, which means we do not send the message to the service bus, so we have data consistency. If our search service is down, do we have data consistency then? Well, this one as well, we would have consistent data because we create the auction in the auction service, save it to the Postgres DB, that's fine. And we post a message to the service bus, RabbitMQ in this case. Now if our search service is down, we're presuming that at some point it's going to come back up. And when that service does come back up, any messages that are waiting for it in the queue will then be consumed by the search service, and then the MongoDB would be updated. So even though the data won't be consistent whilst this is down, eventually it will be consistent once this service comes back up, because it can simply get the message from the queue, which will be persisted until such time as it has been consumed. Now in the case of the MongoDB being down, then we are going to have data inconsistency. And the reason for that is, once again, auction service does its thing, saves it to the database, publishes the message to the RabbitMQ queue, and the search service picks it up. It then tries to save that into the database, but because the MongoDB is down, this is then going to throw an exception. And it's not going to retry after that. So at that point, we're going to have an auction created in the Postgres DB, but we are not going to have it created in the MongoDB because that faulted and it threw an exception. In that scenario, in RabbitMQ, there would actually be a fault queue where that message would go into with the exception, and we'll take a look at that. The other scenario is, what if the service bus is down? Do we get data consistency then? And in this case, that's also going to be a no. We do not get data consistency the way we have things configured at the moment, because the auction service does its thing and saves the auction to the database. The search service doesn't know about any messages, nor does MongoDB, and Rabbit service is down, so effectively we can't do anything. We would get an exception actually from the auction service saying, hey, I've tried to publish a message to the RabbitMQ queue, but I could not because that's not available. So the auction service in this case would throw an exception, but the message would never be delivered to the service bus. So on this occasion, we'd have data in the Postgres DB, but not in the MongoDB. So we would have data inconsistency there. And data inconsistency is one of the challenges with things like microservices, because we do have to think about what do we want to do in certain scenarios. And we need to think about it for pretty much every message that we send to the bus actually. What's going to happen if this happens or that happens? And you need to have a plan to deal with each scenario. And each scenario is different from one another. Some data you might really care about, and you really want data consistency, or some data you just don't really care about because eventually another action somewhere down the line would bring that consistent. In our case, actually, for what we're doing with this auction service, at some point we're going to allow users to place bids. Now that's going to create an event to say a bid was placed, and there's an event that's going to update the auction service just to update the current high price of that bid. If one of those bids fails, then do we really care? Because later on, if there's another bid, that will create another event and would replace that current high bid anyway. So that might be an example where you could throw away the event if it doesn't work the first time. But in the case of our auction creation, then we're pretty sure that we want this to succeed. So we're going to take a look at options of what we can do about this. And what are the options? Well, when it comes to messaging, if we compare this to another type of messaging, such as what happens if you send an email and the exchange or the mail server is down? Does your email disappear into the ether? It does not. It goes into an outbox, and at some point in the future, that delivery of that message will be retried and it will leave the outbox and be delivered to the mail server. And that is one of the strategies we have with RabbitMQ, or Mass Transit, I should say, because that's a functionality that we get with Mass Transit. We can have an outbox for our messages so that if the service bus is down, then our messages can sit in an outbox and they'll be retried at a future point. And when the service is back up, they'll be removed from the outbox and published into the message bus. And we can also retry. So if at first we don't succeed, we try again. And those are the options that we're going to take a look at next.